The 1980s emerged as a dynamic era for artificial intelligence, particularly within the symbolic AI domain, characterized by an initial surge in enthusiasm and subsequent disenchantment. The decade commenced with heightened optimism and an influx of funding directed towards knowledge-based systems, a subset of symbolic AI. This period saw the creation of expert systems like Mycin and Caduceus, which represented significant advancements in many domains, including medicine, embodying the potential of AI to collaborate with domain experts to develop complex rule-based systems. Despite these promising developments, the enthusiasm proved ephemeral as the latter half of the decade encountered critical challenges. The limitations of hardware became increasingly evident, and the intricate designs of these systems presented substantial hurdles in maintenance and scalability. The arrival of more user-friendly personal computers from technological giants like IBM and Apple further diverted attention and funding away from AI research, contributing to the onset of another AI winter toward the decade's end, marking a period of reduced interest and financial backing in the field. During the 1980s, the AI community confronted the common sense problem, which became a critical stumbling block, especially for knowledge-based systems within symbolic AI. This issue underscored the intrinsic challenges of scaling AI systems to comprehend and process broader domains of knowledge, a task that proved daunting due to the existing hardware's limitations and the sheer complexity of human cognition and reasoning. The effort to manually curate and input vast knowledge bases revealed the monumental task of emulating natural cognitive processes, highlighting the fragility of AI systems in dealing with real-world complexities, unreliable data, and the nuanced understanding required to navigate human experiences. Additionally, the period witnessed Japan's ambitious fifth-generation computer project, aiming to leapfrog existing computing paradigms through enhanced AI and computing technologies. This global interest in AI's potential was paralleled in pop culture, with Japan leading the way through iconic anime like Astro Boy and Akira, and pioneering video games including Mario and Donkey Kong. Meanwhile, in the West, the cinematic landscape was shaped by narratives like The Terminator, offering a dystopian vision of AI that captivated and alarmed audiences, reflecting societal ambivalence towards the burgeoning capabilities of artificial intelligence. Amidst the challenges, the 1980s also sparked a resurgence in connectionism, offering a beacon of hope for neural network research. This resurgence was fueled by significant breakthroughs such as the introduction of the Hopfield net and the development of backpropagation algorithms, which revolutionized the optimization of learning processes in neural networks. Parallel computing advancements further amplified these developments, enabling the execution of more sophisticated models and algorithms. This era witnessed the pioneering efforts in convolutional neural networks, laying the groundwork for major strides in fields such as computer vision. The revival and progress in neural network research during the latter part of the 1980s underscored the potential of connectionist approaches to overcome the scalability and adaptability challenges that had plagued symbolic systems. This period marked a decisive shift in the AI research landscape, paving the way for the neural network-dominated methodologies that continue to shape the evolution and application of artificial intelligence. The 1990s were a transformative decade for artificial intelligence, marking a significant shift toward practical applications in the nascent field of deep learning. This era witnessed the rise of intelligent agents, programs designed with the capability to perceive their environments and act towards achieving predefined objectives. This innovative approach spurred the development of multi-agent systems, significantly improving the dynamics of inter-agent communication and their operational functionality. Additionally, this decade observed a vital transition from traditional logic-based methodologies to soft computing strategies, fueled by advancements in hardware technology. This shift enabled the abstraction and implementation of sophisticated statistical models, such as Bayesian networks, which greatly streamlined the development and training processes. These models required substantial computational resources, but offered a reduction in manual labor, illustrating a crucial evolution in AI research that paved the way for more complex and autonomous systems. The adoption of soft computing represented a broader move towards embracing probabilistic methods over deterministic logic, reflecting a maturing understanding of AI's potential to tackle a wider array of real-world problems with increased efficiency and adaptability. During the 1990s, neural networks saw an acceleration in applications across multiple domains, significantly impacting fields like medical diagnostics and computer vision. Convolutional neural networks, through their ability to process visual data, made remarkable strides, particularly in analyzing medical imagery and enhancing the accuracy of diagnoses. Their efficacy was further demonstrated in projects like the MNIST dataset, where CNNs were trained to recognize handwritten digits with unprecedented accuracy. Recurrent neural networks and long short-term memory models brought transformative changes to natural language processing, improving the performance of text and speech recognition systems. This period's technological advancements, however, often flew under the radar of public recognition, despite AI's growing role in addressing complex challenges across gaming, logistics, and autonomous driving sectors. The era also saw AI's subtle yet significant integration into consumer entertainment through innovative games and robotic toys like Furby and Aibo, hinting at the future widespread applications of AI in everyday life and setting the foundation for AI's ubiquitous presence in modern-day technology landscapes. In the 1990s, the development of TD Gammon, a program designed to play backgammon, underscored a paramount shift from expert systems to probabilistic agents, highlighting the practical successes of reinforcement learning. This period also spotlighted the global contributions to AI, notably by the Dutch computer programmer Guido van Rossum, whose creation of Python significantly advanced the capabilities and accessibility of AI technology worldwide. This era of AI research was characterized by a move towards integrating AI with other scientific fields through initiatives like the Semantic Web Roadmap and the adoption of a shared mathematical language, facilitating cross-disciplinary advancements. The decade's exploration of AI and its potential implications were vividly reflected in the cultural zeitgeist, particularly in films such as The Matrix, which captured the public's fascination and concerns about AI's impact on society and the nature of reality.